Okay, hi everyone. Let's talk about equilibrium of rigid body. So let's see how to use a free body diagram we discussed in last lesson to solve these problems. So as we discussed before, it has three equilibrium of equilibrium for rigid bodies, which is sum of all the forces in x direction equals to 0, sum of all the forces in y direction equals to 0, and the sum of the moment on any point, okay, it also equals to 0. Here are the three equations we can use. So the three steps. First one, okay, create xy coordinate for your problem if it's not given. And then you need to draw free body diagram and then apply three equations of equilibrium to solve the unknowns. Some notes, okay, as we discussed before, there are some cases the number of the unknowns is more than the number of the equations. So in these cases, if number of unknowns larger than 3, because this problem is statistically indeterminate system, which means we cannot solve the problem. And also, the order of applying those three equations, okay, also matters in help us simplify the problems. Okay, you will see that later. I'm not always start with using the first equation, sum of fx equals to 0, and then sum of fy equals to 0, and then sum of moment equals 0. Okay, some cases I use the sum of the moment equals 0 at the beginning, so which help us simplify this problem. The third note, if answer to our unknown is negative, which means the direction is opposite of what we assumed. Okay, so let's get started with this problem. So we have a beam supported by pin and A and C. The support reaction is A and C. We need to find it. So what should we do? First, we need to create an XY axis in the horizontal and vertical direction, and then determine if there are any two force members. So two force members is like for the CD members in this equation, all the forces is working on the direction of the object. Okay. Then you need to draw a complete free body diagram of the beam, and then apply the equations of the equilibrium to solve for the unknowns. So here is a free body diagram. So after we recognize that CD is a two-force member, okay, the number of the node and the C is reduced from 2 to 1. Okay, so now using the equilibrium we can get, let's first use sum of the MA equals to 0, which means FCD times by sin 45 times by 1.5, and this is positive minus this one, 4 times by 3 equals to 0. So we can solve FCD, just use your calculator, equals to 11.31 or 11.3 kilogram. And then we use a sum of fx equals to 0. You will get ax plus 11.31 times cosine 45 equals to 0. We can solve ax equals to negative 8.00 Newton. So which means the negative means the ax direction is opposite to our assumed direction. Okay. Third equation, sum of fy equals to 0. We got ay plus 11.31 times sine 45 minus 4 equals 0. And then we can get ay equals to negative 4.00 kilonewton. You can check your answer here. And again, because ax and ay after solving it, it's all negative, which means the reaction has opposite direction to we assume. So we assume ax is on towards the right side. Its actual direction should be towards the left side. Ay, our assumed is upward, but its actual should be downward. Okay. So let's do a concept quiz very quick. So for this beam, how many support reaction are there, and is the beam stable? We have 3 supports. Each of the supports are roller, which means we have 1 force from each of the support. So we have 3 support or 3 support reaction. And is this beam stable? So because of this force, it has some horizontal components, which makes this system unstable. Because all the 3 roller can only provide the vertical support. So this force, it has some horizontal component, which makes the whole system unstable. Okay, this one. The beam AD is loaded and supported and show how many support reactions are there on the beam, and this is problem statical determined, and is the structure stable. We have a fixed and 1 pin, which means we have 3 here, 1 here, we have 4. Okay, so is the problem statics determined? Definitely no. And this system structure stable? The answer is yes. Okay, let's take a look at this problem. We have beam supported by the roller and A and a pin and B. The reaction at the point A and B are on the beam. So establish a XY axis system. Draw a complete a free body diagram, apply the equations to solve the unknowns. So here is the free body diagram. The distributed load, okay, is reduced to a single force, which is 3 times 4 equals to 12. So first, let's use sum of the moment on point A equals to 0. So NA on point B is 0. NA times cosine theta, which is here, times by its distance to point B, which is 4 plus 3 times cosine 30. And this one is clockwise, the moment is negative, and the NA times sine 30 times by distance 3 times by 30 is also a negative moment. And then plus 12 times 2, which is this force times by its distance, and it's a counterclockwise movement, and it's positive. So we can solve the NA equals to 3.7 Newton. Okay, then we can use the sum of the Fx equals 0. We get this equation. We can solve the Bx. And also sum of Fy equals to 0. You can get By. Okay, that's how we solve this problem. Another quiz. So this quiz, I'm trying to show you the order of we apply the equation of equilibrium also matters. Okay, it can simplify our calculations. So for example, here is a free body diagram, which equation of the equilibrium allows you to determine FB right away. So answer should be C, because when we are calculating the sum of the moment on point A, AX, AY, is moment on A point, because AX and AY is working on A point. The distance is 0, which means AX, AY on point A, they are all 0. So we only need to consider FB and 100 lap. Okay, and then we can further decomponent FB into FBY, FBX, FBY times by AB, and its counterclockwise movement, it should be positive, minus 100 lap times by, let's call this point C, AC equals to 0. In this way, we can solve FB directly. Okay, so that's pretty much for today.